So this is just another review of solving systems with substitution. So the first thing we need is a letter that's solved for, that's all alone. And in this case we have an x. So we're going to take what x is equal to. And into the top equation we're going to take the x out and we're going to replace it with what we know. So we have 2 parentheses plus 3y equals 7. So in that spot we're going to be putting 1 minus 4y, and we're going to distribute. So 2 minus 8y plus 3y equals 7. And they're on the same side of the street. It says to add, so negative 8 plus 3 makes negative 5y. Bring the 2 down, equals 7. So I'm going to minus 2 both sides. Negative 5y equals 7 minus 2 is 5. So I'm going to divide out the negative 5, and y is negative 1. So then we want to go back and plug it in for y. So we know y is negative 1 here. So the first thing I would do is multiply these two. Negative 4, negative 1 is positive 4. Bring down the 1, and x is 5. So I have 5 comma negative 1. That's the solution, the x and the y, that work for both equations. Okay, this example, again, we're going to look for, is there a variable that's all by itself on one side that is solved for? And in this case, there is not. But this x looks like it's pretty close to being by itself. We just need to get rid of the 3y. And since it's down 3y, to get back to 0, we're going to plus 3y on both sides. These guys are not like terms over here, so I'm going to put 3y minus 15, or you could have just put negative 15 plus 3y. Either way you write it is just fine, as long as the signs in front of each number, so here and here, as long as the 15 has a minus and the 3y has a negative or a positive in front, then you're okay. So now I know that I know the value of x. X is all of that. So in the top equation, in for x, I'm going to be replacing that. So 2 parentheses plus 3y equals 6. And in that spot, I am putting in 3y minus 15. So I'm going to distribute 6y minus 30 plus 3y equals 6. Well, in this one, we got 6y and a plus 3y over there, and they're on the same side, so I have 9y, because I add them like it says. Bring down minus 30 equals 6. So I'm going to plus the 30 to both sides. And so 9y equals 6 and 30 make 36. Divide the 9 out, and y is 4. So then again, we're going to come back to our equation, and in for y, we're going to be putting 4. So I have 3 times 4 minus 15. Well, this is 20 minus 15 is 5. So our equation, or our x value, is 5 comma 4. And it is a good idea, especially on a test, to go back and check. So if I put a 5 here and a 4 here, I'm going to end up with 10 plus 12. That didn't work. Well, if you notice, it didn't work. And so I just caught my mistake right here. 3 times 4 is 12, not 20. So I'm going to change this to a negative 3 and a negative 3 here. So it's always good to check our answers. So that means negative 3 and 4. 3 times 4 is 12. 2 times negative 3 is negative 6. And certainly that does give me 6. So it works for the top one. So now the bottom one, negative 3. I'm going to put 4 here. Is negative 3. Take away 12. Is that negative 15? And yes, that works now. So glad I checked that one. I'm going to do one more. Just let's say we have y equals 4x plus 5. And we have, let's say, negative 8x plus 2y equals 10. So in this one, we're going to go and solve it for x and y. So we need a variable that's all by itself, and in this case, we've got y. So we're going to be plugging that in for y. So here we're going to have negative 8x plus 2. We're taking out the y, and we're putting in 4x plus 5. So we're going to distribute. We got negative 8x. 2 times 4 is positive 8. 2 times 5 is positive 10. Well, here, negative 8 and positive 8 make 0. So there's no more x's. Those are gone. That's 0. So now I have just 10 equals 10. Does 10 equal 10? And since the answer to that is yes, that means there's infinite solutions. And if you were to graph these two lines, they're actually the exact same line. And that means for every x and y value, they're always going to have every value in common, which is why they have infinite solutions, because the line has arrows and it goes on forever. Another example, let's say we have y equals 2x plus 4 and y equals 2x minus 3. So if we look for the variable that's all by itself, and in fact both of them are the y, so we can pick either one. Let's just go with the top. The y is the 2x plus 4, so we're plugging that in for y. So we're putting 2x plus 4 on this side, equaling it to 2x minus 3. And now, so we minus 2x, get our bombs on the same side of the street. Here we got 0, here we got 0, and we got 4 equal to negative 3. Well, since 4 does not equal negative 3, this means there's no solution. So if we think about the graph here, well, the first equation, I would start up 1, 2, 3, 4, and I go up 2 over 1. And the second equation, I'd start down 1, 2, 3, and go up 2 over 1. And if you notice, these two lines are parallel. That means there's no solution that they're going to have in common. There's no point, no solution point that's going to be the same.